Solar Group presents. This was once just a dream of the skies, the freedom of flight, of round-the-world journeys. Yet we've made it happen. But what did it take? Our dreams became our goals. Our concepts turned into our plans. Our ideas have transformed into a roadmap and production technology. And the years ahead are booked out with development and construction, components and materials, model manufacturing and testing. All this marks the progress from dream to result. Join us on this journey. Solar Group presents a new generation of airships. The best way to predict the future is to create it, so let's do so together.
Hello friends, welcome back to the new Generation Airships project. As always, I'm Fyodor Konstantinov, and with me is Gennady Babanin. We're here for another of our bi-weekly webinars. I'm glad to welcome you all. Let's, as always, do a quick sound check. Please write in the comments if you can see us and if the sound is good. Be sure to leave some kind of reaction. You can already start writing comments. After the main part, we'll go through the questions as usual and answer your questions. I think our connection and video are both excellent, so I believe we can now begin. Fyodor, hello again to you. Hello, Gennady. Let's start with the most interesting part. We recently had another round of flight tests for the NOVA-01 airship. Is there anything you can share or tell our viewers about how the tests went?
Yes, of course. The tests were not completed in full, but everything operated exactly as expected. We didn't have sufficient time to thoroughly test the remote pilot station, but we did manage to successfully test the flight mission execution system. In other words, this is the full autopilot that we will eventually have. We started this program ahead of schedule because everything is clear with the remote pilot, it works. There was a question where you presented the tests, and did you see that there was a minor issue in the code when the cameras were turned on, right? Some systems were lagging a bit. We've already fixed that. The remote pilot station works. We just haven't dared to fly from the office yet. So while it's out in the field, it gives the airship a task, for example a direction vector, and then it flies on its own, fully controlling itself. This has already been tested, and this is a big step towards creating a drone. Well, looking ahead, most likely all the unmanned systems are functioning properly. We just need to finish these flight tests while the NOVA-01 airship is already in the office and disassembled.
So, what is the reason for that? Why did we disassemble it and bring it here if the tests aren't finished yet, so to speak?
We had a clear agreement with the owner of the hangar at the Novinky airfield for a period of 1 month of dedicated work. After that specific month, his hangar is primarily used for housing various airplanes. We were fully aware of all these important details. We planned to finish all the tests within that month, but the weather let us down. And there was also a large amount of ongoing work on the main airship, the NOVA-2. So we had to leave Novinky. We disassembled the airship, of course, and released the helium.
Are we currently considering any additional sites to conduct further tests?
Yes, of course. I think we'll continue the flight tests next week. There are 2 more airfields with suitable hangars that are ready to accommodate us. We haven't decided yet, as I understand. Yes. This weekend we'll go to the second airfield. Everything is already clear with the first one, everything is settled. The hangar, we've got approval from the airfield. and everything is basically clear and obvious with the administration. Now, over the weekend, we'll go check out the second option and choose whichever is better. And starting next week, I think we'll get together and continue flying.
Great. That's truly wonderful. That's probably all for NOVA-01 for now. As for NOVA-2, I know there's already a lot of work being done. There's even something to share.
Actually, I'm thinking, is that really all for NOVA-01? Not quite, to be honest. We still have that mechanism for attaching to the lower mooring point. We haven't had a chance to test it yet either. Yes, because first we need to work out the autopilot system, and only then, in automatic mode, latch onto that mooring point. All of this will also be part of the testing program, but at a different airfield.
And regarding NOVA-01, as I understand it, we haven't piloted it via remote access. But the team was directly on site there and tested the unmanned piloting system, meaning they assigned it certain flight tasks, which it successfully completed.
Yes, and everything works from the office. Right now we have the onboard computer here. Well, it was the same when it was in Novinki. I would send a command from here and everything would be received there. That is, all the data is sent in packets. All the actuators function according to these commands, so everything is working properly. From here on, it's all about experience. At first, it was scary to let it go off the ropes because you didn't know how it would behave. The next stage is to hand over control not to the people in the field, but to those who are hundreds of kilometers away. But I think we've approached this the right way. First, we moved the remote pilot aside, and now we're training the autopilot in the field. Only after that will we start testing the remote pilot. Because if he makes mistakes, our system is set up, the autopilot double checks everything, actions taken by the remote pilot. We'll finish working on the autopilot first, and we'll experiment with the remote pilot. Yes, I also truly believe that everything will work out absolutely great. And speaking of the remote pilot's crucial role, if we smoothly transition to the NOVA-2 project, yes, it certainly seems we've successfully finished the entire design phase. Well, it certainly seems so, because everything is constantly moving and evolving and changing. After all, this is continuous development. The advanced Braille systems, that's the entire onboard complex. Basically, every button, every indicator, every signal, what should be displayed on the monitors, what should be duplicated by separate instruments, which control elements will be incorporated into the NOVA-2, precisely where and how they will be strategically positioned. And now we are commencing the reconfiguration of the remote pilot station specifically for the NOVA-2. For the NOVA-01 it's sufficient, but for the NOVA-2 it's absolutely not. Well, naturally. And if any of you have ever been to a simulator, for example the simulators right in Moscow, where you can sit in one, enter it like a separate cabin, and inside there's a full Boeing simulator, for example of an airplane. The remote pilot station for the airship will be similar. It will fully simulate the cockpit as if you're sitting inside the airship with buttons in proper places. Well, you can also check it out online. The Chinese operate quarry machinery remotely, sometimes even from other provinces. And if you look at how their workstations are set up, there's really a lot going on there.
What's cool is that the same pilot can switch between different machines and control several vehicles or pieces of equipment.
Yeah, it's the 21st century 4G, 5G.
Stable internet connection, reliable communication.
Yes, but in case the stable connection is lost, there's an onboard autopilot, and the onboard computer's power and algorithms are more than enough to ensure nothing critical happens. That's why the autopilot is still the main one, and the remote pilot comes second. Especially since in our country all sorts of things can happen with the connection these days. And this relates to the NOVA-2. The remote pilot station is being designed in parallel with the pilot's cockpit. There's certainly a ton of work to be done in this area regarding the NOVA-2 gondola. Fortunately, everything is moving forward, everything is progressing, the structural and load-bearing design has been completed, and the detailing phase has begun. Many of the solutions are quite interesting. For example, we've arrived at the ballast tank. There are these caisson type structures. The floor will be caisson style, and the ballast tank will be located inside it. All of this has already been designed. Next, it gets assembled. This caisson is joined with the main load-bearing frame. There are a lot of details in these transitional areas. For example, we've chosen the technology, that is, we finalized the technical design, and now we need to select the technology, so to speak. We choose the structures, what they're made of, and how they're manufactured. In local slang, this is called Nutiki riveting. Naturally, this is the fastest method we can use. We simply need to launch NOVA-2 in flying laboratory mode to test all the systems, the engine, the fuel system, the entire aeronautical navigation complex that is part of the control system. It's not necessary to build a full-fledged gondola for carrying 6 passengers. It's enough to make a flying laboratory, so to speak. I lost my train of thought for a moment. There are a lot of tasks related to this gondola. I'm starting to load them up. We made our choice, so now we need to get it done quickly. We chose bent parts, rivets. Everything can be done quickly and clearly. Cut these sheets with a laser, bend them on a press brake. We have the technology and the designer who handles this. He knows the terminology. It's named after a developer where rivet holes are incorporated in the bent parts. Everything is done to final specification. It's bent, you can make the profile, assemble the load-bearing frame, then drill on site. There's a method where everything fits together with pre-made holes, the holes align, and you can easily rivet them together. We chose this particular one as the fastest option available. It's more than enough for a dedicated flying laboratory. Later on, it will be converted into a 5-seater plus 1 pilot configuration. We've even started purchasing all the necessary materials already. So the design and the technology have been carefully selected, and the construction is now well underway. The metalworking facility is fully ready, and Ruslan's dedicated team is already patiently waiting for the detailed drawings. The first 3D models have already started coming out. I realized this from the procurement process. Since we've started acquiring materials and additional tools. The goal for autumn is to have everything integrated with the shell, and it's quite possible that in winter we'll get it airborne, just as we planned.
Well, at least that's certainly the plan for now.
Yes.
Is this the laboratory where the pilot's cockpit will be located, where all of this will be tested?
A flying laboratory, hopefully in the sky. As for the place where we'll take off from, that's still undecided. We have until autumn to figure it out. We need a very large hangar, 50 meters in length, with really big gates, 12 meters in height.
So the search is still ongoing?
It's actively underway, I would say.
What about the NOVA-2 gondola, specifically the mock-up? We stated we're working in this direction.
Well, we've created a full-scale ergonomic mock-up. You walk past it yourself in the office, you see the whole thing. I sincerely hope that we haven't posted it anywhere yet. We haven't actually shown it to anyone, because in people's minds it might seem you know exactly how it typically goes. For example, at exhibitions, they show concept cars that already look like real vehicles. We'll definitely make a mock-up like that. But this one is completely different. It's just a technical mock-up to indicate its dimensions and the approximate interior space. If you want to take a picture, post it.
Yes, we're actually working actively on it. The team is making progress in this direction. We just wanted to bring it to a more or less decent state first.
Yeah, that's absolutely impossible. It's just an external shell, so to speak, made entirely of plywood with those very same plywood seats inside that we were constantly moving around. We carefully measured the door openings. It's precisely set at the exact same height from the floor as the actual real gondola will be positioned on its landing gear, ensuring proper alignment. We went in and out of it, filmed it on video, framed the shots, and observed how it all worked. For example, what posture a person takes when entering, what position they assume to sit down, and how they move to exit. We designed and created the door openings in such a way that everything would be ergonomic. For small helicopters, for example, the dimensions are very compact. Tiny seats, tiny doors. Pilots have maximum height, weight, and leg length requirements to be able to get into the helicopter. Fortunately, with airships, we can make them much more spacious. Even though it's a small airship and you can't really move around very much yet, as you've seen yourself, we're truly trying to make it as roomy and comfortable as possible indeed.
We even fit 2 small sofas in there, so I think passengers will be at least reasonably comfortable.
Yes, as you clearly saw in the detailed 3D models, it's thoughtfully designed for a total of 6 comfortable passengers, with 2 spacious seats facing 2 others in the very back. We meticulously turned the seats into full-fledged luxurious sofas. It genuinely seemed much better to everyone involved that way. Previously, we planned to have one large wide door through which everyone would enter the gondola both passengers, and the pilot would walk between the rows. But we realized that with this ceiling height, for example, Gennady can get through easily, but Vitaly, our designer, wouldn't be able to get through even with a lot of effort and soap. That's why we made separate doors for the pilots. Boarding will be like in a car. You open the door, sit in your personal seat, and close the door. Passengers have a separate door, and now we have the opportunity to install a sofa, since a passage between the seats is no longer needed. That's how it is.
And during these comprehensive boarding and disembarking simulations, we also thoroughly tested all these crucial aspects: the precise placement of the instrument panels, the control yoke, and the entire control system.
Yes, and not only that, did you see, we also have a milled foam mock-up of the engine. We installed the engine in the engine compartment and also simulated
access to it.
Exactly. Spark plugs are located on both sides. So if you look at the nacelle, they're at the front and back. For the rear ones, you can make cowling so you can easily reach them to access all the necessary internal components and assemblies. But for the spark plugs on the nacelle side, access was difficult. The propeller ring drives and the main power frame, which also serves as a fireproof bulkhead, obstructed access, preventing us from reaching them. We really did not want to have to send skilled fitters and experienced mechanics into the confined cabin space so that they could meticulously work on the engine from inside, but unfortunately there was absolutely no other way to completely avoid it. So there will be a special technical window in the fireproof bulkhead, but it's for such situations that these mock-ups are made. Everything sorted out, everything clear, and we're moving into the active phase of building the actual structure.
Great. Are there any other airship models currently being worked on or in development at this moment?
Yes, there absolutely is. We are currently working on an airship with significantly increased aerodynamic efficiency. It is indeed a hybrid airship, yes, with a very high degree of hybridity, and it is designed for optimal performance. Now, the comprehensive design phase has been successfully completed, and the active production phase has officially begun. So in the coming months, we'll certainly see it. It will be slightly larger in overall size than the NOVA-01 airship. It will no longer possess the classic familiar shape. Take a good look. It truly turned out exceptionally well. And it turned out so remarkably well, not primarily because the talented designers simply wanted it that way, but rather because the fundamental principles of aerodynamics absolutely dictated its form. It now boasts excellent aerodynamic efficiency. There is a certain specific coefficient that, let me try to put it into words. Basically, the airship carries some load through aerostatic and some through aerodynamic lift. The ratio of payload weight carried by aerodynamic lift to the structural framework's weight is called efficiency. And this efficiency has been achieved. It's measured in numbers 1, 2, 3, 4, 5, up to 20 roughly for the most advanced airplanes. I might be mistaken, but airships had a theoretical limit, and we managed to surpass this theoretical limit in terms of efficiency. It will have 4 main propellers. The NOVA-2 only has 2 tilting ones. This particular model will feature 4 primary propellers, in addition to 2 more dedicated cruise propellers located at the tail section. All in all, this is truly turning out to be a very interesting and innovative project indeed. When we were purchasing absolutely everything, for example, for the sophisticated control system, for the NOVA-01, for the powerful engine, and so on, we deliberately bought everything in triplicate. So we already have approximately 80% of all the essential electronics, advanced computers, robust engines, and intricate wiring. Right now, the shell is being manufactured. At the same time as the shell is being made, the production of the power elements is also starting. On the NOVA-2, this was the gondola, basically the tail assembly. Here, there won't be such a gondola. Here, there will be 2 distinct engine nacelles positioned on the sides. This will be low, quite narrow, and notably long and a single. Prominent nose gondola will be present for the essential payload. It is situated right at the very front, and it truly looks very ergonomic and well designed. We're starting the production of their structures, and we're purchasing everything, and in the summer we hope to fly it already.
Are you working in this direction, specifically with Dmitry Sergeyevich Khmel?
Yes, this is entirely his personal project. Let me remind you that we have Vadim Vasilievich Zubkevich, who is the chief designer of the NOVA-2 airships, which are of the classic traditional shape, and the NOVA-8 airships. But Dmitry Sergeyevich Khmel is an advocate for hybrid airships. Over the course of his career, he has designed a great many of them for various clients and has finally come up with that very ideal formula.
It's time to move on to practice.
Yes, finally, it is.
Great. Do we have any significant new additions in the office itself? I know that in the production department, we've recently got a brand new small laboratory. Shamil personally showed it to me. They just bought a really impressive new 3D printer there.
Your information is a bit off. We actually moved the 3D printer from our old lab, just like we did with about half of our scientific equipment.
How is it different from the 3D printers we already have?
It's the technology used to create the model, the actual product. Here the filament is melted and layered on top of itself. It's a wonderful technology for its intended use. That particular 3D printer is photopolymer based. It meticulously creates 3-dimensional objects from liquid resin using precise ultraviolet light exposure from below through a specialized matrix, thereby achieving an absolutely incredible level of precision that can be consistently reproduced. In general, they do some interesting things there. Right now they're using this printer with a special burnout resin to make a piece for casting. They probably aren't getting into the frame again. If they are, then it's things like this.
Is this already a part of what we are making?
It's specifically for the power unit of the NOVA-8 airship. Yes, we're also diligently finishing up its design. We're now moving on to releasing the design documentation and sending it into full production. I know that Ruslan has already purchased a significant amount of heat-resistant materials for this particular part. On the rubber machines that we have acquired as part of this important project, he's already cutting out blanks, and they're starting to manufacture parts for this power unit on 5-axis milling machines. Yes, so we've already started production. The 3D printer is specifically for critical parts that are meant for casting. Of course, they will definitely undergo post-machining afterwards. but the shape is very complex. It's quite possible that the first such molds will be fully cut out on a 5-axis machine from a solid billet, but for transitioning to mass production there is a special casting technology. First, this form is precisely printed, and then it is repeatedly dipped into a ceramic solution, which then dries layer by layer. As a direct result, you ultimately get a robust ceramic mold like this, into which you then pour molten metal. It effectively burns out all of this resin, leaving behind the precise cavity. We will be mastering this process, and while we do, we'll machine, assemble, and test everything on 5-axis machines to see how it works.
And for intricate parts like these, you really need much higher precision printing of the sample components. Yes, of course. And now we also have a fully equipped laboratory that allows us to do just that. Fyodor, can you please tell me if we've had any new promising team members join us recently, perhaps some young and exceptionally talented individuals?
Where are you going with all this?
I'm talking about that very intern who just joined our team very recently.
Right. You released news for us from St. Petersburg.
How did that even happen?
They sent a message. The teacher wrote to us. As I understand it, the students typically go to a certain organization outside of regular school hours, where they are carefully guided toward a future specialty or career path. And they choose the specialty themselves, and it just so happened that this student, Mikhail, chose aeronautics on his own. He started a project to create a small, really tiny device, and as part of these courses, an internship is required. Yes, he found our project, our company on his own and said, I want to do my internship with them. And now he's been here for a week, learning the basics. We went through everything with him to see what exactly interests him. He looked at everything and said, radio electronics is interesting to me. I have a lot of tasks related to it, and 3D printing is interesting too, so he finished learning the basics of radio engineering. Denis meticulously taught him how to skillfully create specialized and innovative devices that could work effectively and reliably from a distance, performing the precise and essential functions he specifically needed. And starting next week, he'll be getting involved with printing. He says he wants to master the process of modeling for printing. Obviously, anyone involved in engineering needs to produce parts. For that, a printer is very convenient. You're as independent as possible. You design it yourself, send it to print yourself, process it yourself, and assemble it yourself. So he's switching over to this process now. We're teaching him.
He plans to create his first airship in 3D modeling. We'll print it out and ceremoniously present it to him as a talisman, as a memento of this internship.
He has a very specific task at hand. He has already assembled his own small one, and there are a number of components that he needs to replace, transitioning them from mock-ups to fully functional ones. These functional parts, he'll print them here, he'll design them himself, print them, take them back, and install them. Through his internship, he'll master 2 professions, an entry-level one in radio engineering and modeling, and 3D printing.
Overall, it's really great that we found such a person quite young who surprisingly is passionate about airships. It's truly great that he managed to find us at all, and it's probably doubly nice that we were able to genuinely help him and give him the wonderful opportunity to do his internship here. I think that's absolutely awesome.
Yes, I think there's even more to come.
Maybe in the foreseeable future we'll even see him as a valuable and integral member of our team, who knows.
A lot of people reach out in general. Among them are young people and students, as well as those who graduated from university a long time ago and are already working. Guys, we want to participate, we want to be part of the team. Where should we send our resume? Or I know how to do this or that, please let me join. For now we're moving everything in emergency mode, sorry about that. It's difficult to organize all of these, but please don't lose your enthusiasm. Very soon, when the team starts expanding, you'll be among first on the list.
So where should we send our resumes, if anything?
To the official email. If we haven't sent it anywhere yet, just know that we've set up an official channel specifically for the company, AERONOVA Node the new Generation Airships project, but the actual manufacturing company, the AERONOVA Design Bureau, and its social media, and there you'll find official resources and their respective email addresses. So we probably need to post that important link somewhere in the chat today. Go ahead, please do join, subscribe, and then send your resumes there.
Great.
Yana reminds me the website will be up soon. Yes, an official company website will list all official resources, which you can use for this as well.
Awesome. We also had some really exciting news recently that we've started making significant progress toward the piloting school we announced a little while ago. And just very recently, there was even an update saying that we're already taking some concrete steps in that direction. Can you tell us more about it?
Yes, Sergey Bondar spoke at our first conference in August. When we announced the pre-launch, he talked specifically about the school. He explained why all of this needs to be done and said he was ready to get involved in the process. And now it turns out that we have understanding, at least in general terms, of the first airship show. The airship will interact with the pilot, what systems will be installed there, at least some idea of its dynamics, and so on. In other words, we now have a foundation on which we can start creating educational aids and materials. Yes, we've started this process. It's not a quick one. In addition to creating these instructional materials, they also need to be coordinated with and approved by Rosaviatia. Then we can start training pilots. We've initiated and are actively developing these methods and implementing them through Rosaviatia.
So very soon you'll be able to obtain a license not just for a car but for an airship as well.
That's how it turns out.
It's definitely on my to-do list.
Look, piloting an airship is certainly a very interesting experience, but we're actually making it so that it operates in a completely unmanned mode. The drone will be in full control, but you can still truly feel like you're the one personally piloting it.
Modern cars today are also packed with electronics, and you could say they practically do all the work for you. There are already so many cars with automatic parking and other features.
Yes, and it's actually easier to implement this with an airship than, say, with a plane or a quadcopter. Although planes and quadcopters can already fly on autopilot too. Yes, so with an airship everything will be much simpler. If there are still some risks with cars full autopilot, can be scary because there are so many things on the road, including other vehicles, poles and guardrails. Then in the sky, as long as the sky isn't crowded with airships, it's completely safe. Compared to a plane or a drone, engine failures in an airship don't pose any catastrophic danger at all. So I expect to travel comfortably in an automated vehicle that I can communicate with by voice.
That would be absolutely wonderful.
It even has a name. Right now it wants to ask where we are flying. You tell it knows. It replies understood.
We're taking off.
Yes.
Fyodor, tell me, have there been any important or perhaps major purchases recently?
Yes. The significant shell production initiative that we proudly announced during the big webinar. We have already paid for most of the essential equipment. Back then, the issue was that we hadn't made an advance payment, so the manufacturer hadn't started preparing it. We made some modifications, placed the order, but the work hadn't begun. Now everything has been fully paid for in advance, the work has officially started, and I truly think we'll receive everything by the very end of the summer season. Now, the same crucial task still remains to decide on the precise location where this equipment will be installed. We've made advance payments for most of the most expensive equipment, but some of the equipment was paid for in advance. We recently made the final payments and the equipment is already on its way. The cutting table and the tensile testing machine, they are already on their way to us. As for the high-frequency welding machines, there are two types. They have only just started being manufactured for us. There's nothing complicated in terms of modifications. The smaller equipment has also been queued up for purchase. Now we need to decide on the location. We have a number of, so to speak, production sites that we've identified. Starting next week, we'll begin visiting them, taking a closer look, and considering renting them. Of course, there are a couple of properties that seem to say, buy me and restore me.
And in some significant ways, that might even be considerably better.
But again, it all truly depends on the available money. To buy me, that is certainly quite expensive. To rent me, even if it's just for a period of 6 months, that is not much at all. It is ready to go, conveniently nearby, and impeccably clean.
And don't forget, we're in Moscow and prices here are completely different.
Yes.
There was also information in the chats that the fabric has arrived as well, the shell fabric.
Yes, hallelujah. It's here. Everything's great with it. It's just sitting there, waiting for the machines.
This is the very one we were expecting, the one we ordered.
The quality matches the declared strengths. We'll use it to make the entire envelope for the NOVA-2 airship. From the Babanin fabric, which is used for the Babanin in the NOVA-2, we'll make another modification of the NOVA-01, because there are some questions about this fabric.
Right, the one that we have just mentioned at this very moment in time.
I don't know. Maybe it'll be another modification, we'll see. Yes, there is indeed market interest in the NOVA-01. No, the envelope is not flammable. It does not support combustion. Here's a question right away. If you were to attempt to burn this material with a powerful torch, it would, of course, eventually burn through its surface. However, it absolutely will not sustain combustion on its own, and it certainly will not flare up in any significant or dangerous way. There might be another significant modification, perhaps, because, yes, as I said, there's now demand for small airships. The market is responding, saying, can you solve this kind of problem for us? Can you make an advertising one for us? And in some cases, the classic shape with improved aerodynamic efficiency might be best, while in others, the traditional design will surely do the job. Right now, we're working out our understanding in this particular direction, and that's where we'll effectively use this fabric. In short, to put it simply, there is a client for a small airship.
Plus, they are easier to manufacture. We've already done it, and we can do it again.
We certainly can indeed.
Because our very first 01 was, let's just say, a much more technical model indeed.
A scale model, a dynamic replica of the NOVA-2 airship.
Together with Dmitry Sergeyevich, we are working on an aerodynamic model of a more hybrid type.
Yes, it's also a scale model of what will be built after it.
And we would really like to make a classic version of this one.
Let's call it the optimal one. Optimal in this particular size for the specific tasks that the aerodynamic efficiency of a hybrid airship is 6. Just answering the question, that is all. Optimal, yes, for advertising and micro-monitoring tasks. Its concept is crystallizing thanks to external orders from various sources. Everyone is talking about roughly the same size and about the same requirements. So we are finally shaping the external appearance not based on expert opinions, but on external requests. And it's for this task that the fabric has been made.
And it will turn out that in this volume of 130 to 200 cubic meters, we will already have a ready offer for the market. A more hybrid option with good aerodynamic characteristics and a more classic version.
In practice, we'll test both the first and the second, and then it will become clear. For example, the task of loitering over a certain area for a day, which one will handle it better. Of course, these are just theories. We'll be able to test all of this in practice, and for such tasks we'll use whichever option is better. For other tasks like a promotional flight that lasts 2 hours, for example, there's no need to make a complex aerodynamic shell. It will be enough to use the classic design.
What about our first airship, the NOVA-01? Would its fate be, so to speak, after the next two are built?
Its fate is to fly, and fly again, until it wears out against the air, until we get NOVA-2 airborne in unmanned mode. NOVA-01 will keep flying, the autopilot will keep improving, the algorithms will be refined, the models will be adjusted, but that's it, it will keep flying.
Great, so I suggest we slowly move on to the questions. As I understand, we already have some. If you have more, be sure to write them in. We'll be here to answer.
So, Yuri is asking about gliding from an altitude of 1 kilometer to cover 6 kilometers without turning on the engines. I'm not an expert in such details, you'd have to ask the aerodynamicists, but they say the glide ratio is very good for an airship.
Alright, first question. Were you able to recover the helium from NOVA-01?
No, we contributed to stopping global warming. We released the helium into the atmosphere.
Yes, because this question did come up and we considered such options. But it seems to me that it's just not feasible.
Buying a helium compressor to squeeze it all back into cylinders would cost 100 times more than just releasing the helium and refilling it again.
Alright, next question. Sergei Semyonov mentioned a potential buyer or buyers for the NOVA-01. Has there been progress in this direction? Certification if needed, or purchasing equipment for manufacturing envelopes, air steps being taken?
Yes, of course. We've carefully put them in the production queue with only very minimal, almost negligible deviations from the original meticulously crafted models. The units will be produced after we successfully finish building the much higher quality airship we are currently working on right now. They should be readily available by the end of the summer season or the very beginning of the autumn period.
That's certainly the plan, at least for now.
They are scheduled to be ready soon.
Next important question. Which specific model do you currently plan to send to the upcoming air show in the fall season?
Most likely the model that will be ready by then. The one Sergei Semyonov mentioned, it's quite possible that it will go to the air show, and most likely also a beautiful concept mock-up of the gondola, if we manage to create it in time, of course.
A more presentable one.
Not more presentable, we are not even considering that. We simply don't have the option to create it from scratch.
So you will have the option of NOVA-02, not NOVA-2, but specifically 0.2, meaning for 200.
200 cubic meters. I don't really think so, but we will see. If you can introduce this Khmely airship there, by the way, that's the specific term he uses. He calls them aerolets. It's still not a dirigible that flies entirely on aerostatics, but also on aerodynamics. And he himself said, let's call them aerolets. At first, the term sounded a little bit odd and unusual to me, but then I gradually got quite used to it, and now I can clearly see them being called that. So now we're going to launch an aerolet, a small lightweight aircraft.
And basically, we're just going to fly?
No, what I want to say. I was just recalling the question about 200 cubic meters. We're going to launch the aerolet, which turns out to be the NOVA-15. So it's not 100 cubic meters, but 130 cubic meters, of which we filled 110 with helium. This one will have 130 of helium, plus the ballonet, so it will be around 150. It's quite likely the next one built after this, the commercial one Semyonov mentioned, will most likely be the 200 cubic meter version. That will be something like the NOVA-02, but it will be Aerolet 02.
All right, great. Let's move on. There are currently Russian navigation systems available. Which ones do you plan to install on your aircraft?
It depends on which navigation systems you're referring to. If you mean GLONASS, it's already installed. If you're talking about specific onboard systems, we develop all of ours in-house.
Alright, so this question is rather ambiguous. How much cargo can the airship carry? It's not clear which model they're referring to, perhaps the Aerolet.
Well, it ranges from 50 kilograms up to 300 tons in the foreseeable future. And then, what about the Aerolet? Yes, what's the difference? The small Aerolet can carry 50 kilograms. 50 kilograms? Yes, and then, by the way, regarding Aerolets, there's something very... I've already tried to explain this, and I won't go over it all again. But hybrid airships do have a certain size window where they fit, for example, from very small up to this size. Beyond that, it's a return to classic forms and aerostatics, because you can't cheat the laws of physics. The volume increases cubically, and the aerostatic lift increases cubically, while the area grows quadratically. Aerodynamic efficiency will have less impact on the overall payload capacity. So the aerolift has a payload ceiling. I hope it will still be somewhere around 60 tons, but beyond that, it's all about aerostatics.
Great. So, friends, I'm reading your questions and I have a big request. Please formulate them more specifically and clearly, because you write them while watching the webinar, but we read them later. And it's not always clear what a particular question refers to. Here's one of those. Will there be a table provided like on airplanes? I assume this is a new feature.
Yes, will there be a table? While we were sitting in our mock-up, we realized that a table is necessary. At the very least, to put your phone down and set a cup of coffee.
Yes, and it's already included in the mock-up.
But for now, there's a chair instead of a table. But yes, of course there will be one.
What kind of internet connection can be when transporting cargo somewhere in the taiga, where there's number 4G?
There, the autopilot will make decisions independently. Naturally, it will navigate using satellites and the terrain. That's something we can do, rather, something we can't do yet. Right now, for example, we're working on this task as part of developing stratospheric systems. So, when a stratospheric probe flies far away, where there are no towers or anything else, and you can't even reach it by radio, we transmit all telemetry through satellites. And here the task will be solved in exactly the same way. When airships fly deep into remote areas, all telemetry will go through satellites. For example, we'll receive commands from it and send commands to it via satellite. We might have to use a more advanced satellite than the ones we are currently working with. Alright, the autopilot will now handle everything from this point forward.
Got it. So, I've sent a potential design for an airship with a PD-8 type power plant in the chat. They're asking if you've seen it.
Yes, I saw it with its distinctive nose bell and a prominent channel running through the entire body of the impressive airship. I also came up with similar ideas like that at the very beginning, when all this truly started, and experienced engineers gave me a clear answer as to why not. I don't remember it exactly, and I definitely can't articulate it now. It was something related to the increase in total surface area subject to friction. Like when you only have the outer shell, you have just one wetted surface area. But when you have both an outer and an inner surface, the area is almost doubled, and so is the friction. And all the advantages you might get from this formula are offset by the drawbacks: increased mass, reduced usable lifting volume because you remove that internal channel, increased friction, and for some reason increased instability as well. When the frontal resistance accumulates at the nose, it actually provides a kind of support that helps stabilize the airship. And when it's not there, they say it becomes harder to stabilize. It's called yaw, I think. The terms are pitch and yaw in aviation. It's like when rockets launch into space, I remember hearing something about that.
or turbulence in aviation.
Someone is definitely listening.
All right, friends, thank you so much for your suggestions. As you can see, we read and consider all of them, so be sure to write in. If you have any ideas, if something comes to mind, definitely send them in. So, here's the next important question. Will there be private orders for these magnificent airships? Will they actually make airships for individual families?
Like, will someone be able to buy a family airship?
A house on wheels without the wheels.
Well, there are actually people, yes, who do indeed buy yachts, not just the ultra-wealthy billionaire ones you often see on the internet, though even those truly magnificent vessels too. Yes, a lot of people can afford yachts. I don't even know. You could Google it, by the way. It's actually really interesting how many yachts there are in the world, at least two-deck ones, or just cabin yachts in general. And that's precisely the audience that will be able to comfortably afford to buy a family airship.
Yes, I think it's definitely an interesting direction, because there are people like that.
And there are countless numbers of them, and their whole life philosophy actually fits with the airship and living in an airship, because many of them really do live on these yachts. Today they are on one coast, tomorrow on another, so it's like an apartment on the water for them.
But here, you don't even need a coast.
But still, you have to park somewhere, maybe in those same base. Why not? It's very beautiful. So I think, yes, everything will work out.
Excellent. All right, next question. So, at the present moment in the commercial sector, apart from AERONOVA, are there truly no other companies working in this specific field? I mean, specifically commercial airship manufacturing companies.
Yes, most likely there are no state-owned airship manufacturing companies in the world. All the ones that exist are commercial. But I'm not sure about the Chinese one. It seems to be some kind of national institute. The airship is for the domestic market, but again, it was created and certified by them. Then comes commercialization and tourism, so they're all commercial. The real question is what stage each company is at and which direction they're moving. That's very important. AERONOVA has a unique path.
No doubt about it. All right, next question. There were posts in the chat saying that high-ranking officials might be present at the airship's first flight. Is that close to reality?
The very first flight, probably not necessarily the absolute very first one, but at a significant demonstration flight of the NOVA-2, of course, there will certainly be. After all, this is truly serious and important equipment.
Currently, the innovative field of cargo transportation by advanced unmanned quadcopters is rapidly developing and expanding across various sectors.
A thought occurred to me. Let me interrupt. The highest ranking people are actually the engineers who create the technology. They are the most valuable and they will be present at the first flight. They are present.
But they won't be the very first to fly. They're simply too valuable. Right now, cargo transportation by drones is rapidly developing. Will the airship truly compete with them, or are these entirely different niches?
No, it's all one big interconnected world in unmanned aviation. Each platform has its own distinct capabilities and specific tasks, and the airship fits in very well there with its truly unique features. So it's great that we started right during this unmanned boom, when the brains have appeared, the legal framework is being formed, and there are a lot of, let's call them perks, from the government, including, for example, opening departments in institutes dedicated to unmanned systems. A lot of specialists are being trained in this field, and that will naturally help us as well. So the airship has its own unique niche, and it will definitely claim it in the unmanned market.
As for the assembly building, nothing has still been decided yet.
The significant question of exactly where to assemble the NOVA-2 is still being carefully resolved.
It turned out not to be so simple.
Well, everything happens in its own time. I've never seen anything here that didn't happen on time. Well, not on time somehow. Things always seem to happen just when they're needed. A problem arises, a solution appears, a problem arises, a solution appears.
All right, good. Do you consider hybrid airships to be truly promising? They inherently lack the main advantage of classic airships' vertical takeoff, don't they?
No, that's not true. Why? Because this is sold with tilting rotor seat, can also take off and land vertically. Yes, it does require energy in that mode, but later it compensates by switching everything over to aerodynamics. But hybrid airships have a very interesting feature. They can be completely ballast free, which is a problem for classic airships. It can remain in a state of equilibrium when it's not loaded, carrying all the cargo with its rotors and body, that is, through aerodynamics, and then after unloading it returns to equilibrium or continues flying further. In general, any serious craft, whether it's an airship type or an aeroflight, torpedoes don't really matter. It is specifically designed for a particular task, and everything can be effectively combined. And hybrid types, classic types, ballasted, non-ballasted, with active ballasting, with heating, and so all of that depends on the specific task. If the task is transport and logistics, where you truly need to count every single penny per ton per kilometer, then most likely there is already a clear and well-defined route and specific points. That would be a truly minimalist classic type airship with all the inherent pros and cons that naturally come along with it. If it's some kind of special task where you don't have a specific unloading point and no one is going to prepare ballast for you, or if you have to transfer cargo somewhere, that's when inventiveness comes into play. You either create an active ballasting system or consider increasing the hybrid capabilities of the airship. But there, for example, you have many variables, and there will always be a path where you combine something from here and something from there, and everything will come together not to an ideal result, but to exactly the result needed to solve the specific task at hand.
So, to sum up the answer to the question, hybrid airships are also promising. They also possess the inherent capability for vertical takeoff, but they will simply expend more energy on it due to the powerful engines working, and the subsequent aerial flight will then rely primarily on aerodynamics. During the webinar, Sergei Semenov mentioned that there would be another platform for attracting funds, which is approved by the central bank. What is this for? Could you elaborate?
That's Pavel Filipov's area, so let him explain it, please.
Well, probably, yes, that's not entirely my area of expertise. However, have you thoroughly considered the intriguing option of utilizing large airships as a truly unique and expansive mobile museum complex?
A museum?
Yes, that's what it says. A museum. Why not? Any options are possible. Museums, swimming pool, even complexes built there. Why not?
Well, the first thing that comes to my mind is if, for example, an expedition airship flies along the Northern Sea route, you could have a separate hall there with mammoth tusks on display.
Yes, why not?
Anything is possible.
Besides NTV, have other media outlets or popular tech YouTube channels shown interest?
There has been some interest. AERONOVA has a press center that handles it, so some things you see and some you haven't.
Everything in its very own time. Stratospheric airship show. Many more years from now, do you plan to begin producing and launching them?
Well, realistically speaking, if you carefully consider the whole situation, it's definitely not a top priority for the next 3 years. This particular technology is very complex and inherently intricate, presenting a lot of significant unknowns and unresolved challenges. No one has yet, for example, successfully demonstrated a viable solution or a clear path forward. Our engineers have also participated in the development of leading stratospheric probes, not only for many domestic companies, but also for various other entities. But when it comes to an airship in the stratospheric sense that we envision, that's a very serious and entirely new kind of technology. And naturally we are moving in that direction, and we understand when exactly we will achieve what we are imagining. It's something large, freely moving in the stratosphere with a significant payload on 2 or even 3 tons, and capable of performing this work for months at a time. I think we'll be ready to start building something like that in about 3 years.
Well, plus, this is still uncharted territory if airships were used, and there's experience. Have stratospheric ones ever been launched or existed?
Yes, any kind. Look, the Americans recently posted a video. They supposedly launched stratospheric airships, but their size is about the same as our NOVA-01, maybe even a bit smaller. I don't remember exactly. For some reason it was silver. It looked like that, but it didn't really stick in my memory, because after all it's just a toy. It flew there with a tiny payload, and you could send something like that up there even this year. Yeah, but the point is, you need to accomplish the set objectives, and those objectives require lifting serious equipment up there. We've already launched small stratospheric probes with altitude control, and we'll be launching more in the near future. A lot of work has also been done recently on developing key technologies specifically for super long duration drifting probes. This comprehensive redesign includes specialized gas release valves, significant work on the fin, and overall all the onboard equipment has been completely redesigned from scratch. A whole range of different systems has been created, including the system for releasing the devices themselves. It's very difficult, yes. Arkady is his name. He is the main executor and creator of all this work, and in the near future we'll be launching the probes again, while all this actually they're being launched even now. We just don't widely publicize it because we don't have enough available hands. For now they're still primarily scientific and technical. If we need to test a specific component, it gets sent up on large latex balloons. For example, if we need to test valves, that's done with large envelopes. Sometimes we need to refine the mathematical model or measure infrared radiation somewhere. We need to fly there and figure it out. We need to fly in cloudy conditions, in clear weather, over water and over land, to calibrate all models. There are several systems for changing altitude. We need to test the first, second and third, and all this work is ongoing. And all of this work will likely lead to us launching propeller motor groups on these probes by the end of this year or the beginning of next year. And eventually this probe will gain the ability not only to change its altitude vertically, which is currently being developed, but also to move laterally across the flow. These two will provide really enormous possibilities for controlling the probe, and it will essentially become a small airship. Yes, it won't be shaped like a cigar, but that's not necessary. An airship simply means it's steerable, and that's exactly what it will be. It will be controlled primarily by an autopilot system. Everything will rely on the data it collects on its own, precisely where it is, how it is functioning, where it needs to go, because communication with these devices is, I would say, still rather complicated and quite challenging to manage. Everyone is working on this task as well, but as for sending it commands from any point on the planet to any point in the stratospheric orbit, I don't know how that will be done. This work is ongoing, but essentially it should also be able to make decisions on its own. Well, on its own, all of this is programmed into its algorithms, so to speak. According to the algorithms programmed into it, there will be a small airship. As for a large one, to return to the main point, it will take a long time. It's complicated, but we'll get there.
Alright, for our next question. It's quite clear that vacuum aerostats are indeed impossible on Earth, but a very interesting query arises. Are they potentially possible in the Earth's stratosphere? That's something out of futurology.
That's something complicated. Yes, if you try to create a vacuum airship on Earth, it would sink in water. That's a common, well-known joke among airship enthusiasts. It absolutely wouldn't float to the surface. The shell would need to be so incredibly dense that it would sink like a deep-sea submarine, or even worse, perhaps like a lead weight. But for the vast stratosphere, the atmospheric pressure isn't as high there, which makes a significant difference.
but you have to assemble it.
In general, there are specific terms often used by experienced engineers. Something about the critical loss of structural stability under significant compression, and these are inherently the most unstable structures imaginable, and the vacuum airship is exactly that. And they all universally say it's absolutely taboo to create products with such inherently problematic properties. So it's highly likely that even in the extreme stratosphere, it would still be considered completely taboo.
At least for the time being, for now.
Yes. After all, the stratosphere is made of very delicate envelopes. As the air there is extremely rarefied, and as Archimedes' force decreases, density drops, the lifting force and the apparatus mass must also be critically reduced to stay there. But a vacuum still implies creating a strong shell.
It would be very quite...
Heavy?
Yes. Alright. Is there any ongoing cooperation with the limited liability company Sovelmash?
Not yet.
Okay, next question. A request to the team. If there are any secrets, please speak about them figuratively. This is still business, and it's important to keep some distance. Apparently we were a bit too candid at some points, I gather, given such recommendations.
Yes, but it's quite possible that this viewer is so immersed in the context that they understand everything figuratively anyway. Yes, and I agree we could say a bit less, but overall there don't seem to be any risks on the horizon at the moment.
Alright, so I truly believe that in order to finally establish airships as a reliable means of air transport in the world, we absolutely need to build very large ones, up to 500 tons. How do you view these prospects? Naturally, these are indeed being considered.
As quite feasible, and of course, yes. In order for airships to become established in this entire field, one of the important qualities we need to genetically instill in airships is all-season capability and regular scheduled service. Of course, both airplanes and helicopters are also sensitive to weather conditions. If the wind is coming from the wrong direction, blowing onto the airfield, not every plane can take off from there, and not every helicopter can land just anywhere, and so on. An airship is also sensitive to the weather, perhaps even more so, or at least in a different way, than airplanes and helicopters, but it has its own kind of sensitivity. For example, the business community perceives airships that they only fly in clear, windless, sunny weather, but what if I need to transport something weekly? Will it fly in a week, and then again in another week, and another week? But what if it rains or if it's windy? Let's say it's a light rain or a light wind. But what if it's heavier rain or stronger wind? I'm not going to wait a week. So will you fly or not? Well, we will certainly fly. This truly needs to be demonstrated. And that's when the main question will be resolved, because it's impossible to use them in a transport and logistics chain unless you can ensure some kind of scheduled service and all-weather capability, regularity. Yes, of course, carrying 500 tons is really impressive, and you can show and prove that, but this quality is a bit more important. We're working on it.
Have you successfully collected enough data during the recent flight tests of NOVA-01 to adequately train the AI?
It's hard to say. Here again I'd have to give a lecture about how we don't plan and never planned to entrust everything indiscriminately to artificial intelligence. A significant amount will be developed using meticulously handwritten algorithms, and as for what we actually entrust to advanced artificial intelligence, those crucial data didn't necessarily have to be collected during the actual flight. For example, sophisticated computer vision systems, precise docking masts, and specific docking base points. It should be able to recognize them and, based on that recognition, send some information to the flight controller. Then, based on that information and its algorithms, it guides the airship to those docking points. So we have now successfully collected a sufficient amount of comprehensive data for the extensive autopilot algorithmization process, and in those specific areas where it is truly needed, we have not yet commenced the essential training procedures. There are standard AI systems that don't need training, they just work. There are others that are custom built. For now, they're just sitting there processing. We should definitely invite Melada to the upcoming webinar so that he can thoroughly explain to you in much more detail which specific systems we are currently planning and at what precise stage they are. Alright? If you understand English, be sure to join us. Although now, with AI, you can translate everything into Russian. Yes, in real time. It's just one click, so it'll be fun.
Will the airship be able to deliver cargo and people to moving platforms like icebreakers or ships in high winds? You actually touched on this topic a bit earlier.
Yes. An icebreaker isn't exactly a nimble, high-speed Formula 1 car. It moves at very low speeds, follows predictable routes, and is quite sluggish, so all the automation can easily predict its movements and deliver everything as needed.
What is the payload capacity of the NOVA-2? Is there a plan to use a hydrogen-powered version?
500 kilograms or 500 kilometers. That's the formula we expect from the NOVA-2. As for the hydrogen version, it's not even being considered at this point. Helium is more than sufficient for it.
Alright, I think we've thoroughly answered this question as well. The primary and fundamental features of the terrain are generally quite static. Mountains, lakes and rivers typically don't tend to move. Are you planning to develop machine vision for navigation before the high-altitude airship enters the radio control zone?
This is actually one of the primary tasks currently assigned to advanced artificial intelligence, yes. Based on comprehensive data from Yandex, Maps, Google Maps, and various other detailed aerial photographs, we are currently developing a sophisticated model that will precisely determine its geographical location by meticulously analyzing the surrounding landscape. There too, we are currently facing the question of whether it might be easier to algorithmically solve this ourselves rather than relying entirely on artificial intelligence. But yes. Thank you for the question. You see, I appreciate it.
So, can the aeroplane perform vertical takeoff and landing? We've already answered this, yes it can. How many airships are planned to be built by 2030? And will we be making airships for the head of state?
I hope many, and I hope we will. 2030 is still 5 years away for us. Which ones?
It is currently 25 now.
Well, I see half the time has already passed, 4.5 years left. I hope so, but I'm counting on it.
At the least I plan to...
The soft ones are already being mass-produced, and the rigid ones, there are definitely 1 or 2 of them. And I sincerely hope the head of state will truly appreciate it by then.
Yes, we'll reach out with pleasure.
We will certainly build one for him too. Perhaps it will even be flying by then, you know.
Along the Northern Sea route, airship. Launch a bathhouse airship along the Northern Sea route?
Well, you order it, we'll launch it.
Yes, we'll do it. Do you plan to launch passenger airships only using helium? What will be the actual difference in payload capacity between the helium and hydrogen versions?
None. There's only a couple % difference in payload, but a lot more problems. And people will never fly on hydrogen airships. We only consider hydrogen as a lifting gas for stratospheric unmanned platforms. Yes, first of all, they're high up, they're far away, there's no oxygen there. So the mixture becomes completely safe. And everything near the Earth will be operated on helium.
Alright, that's perfectly clear too. So, could you please tell me what kind of fabric do you typically use for the envelopes?
It's just purchased.
Well, I guess they are indeed asking about the name, if you happen to remember it.
It's hard for me to communicate in hieroglyphs, when it comes to technical terms, you should ask Zubkevich, like how many decitex per centimeter. As for the composition, we received some samples from Victoran, but they turned out to be a bit too heavy. So, Victoran is the base. Impregnations and other details are commercial secrets. Then there are ultraviolet layers and titanium oxide. These are protective films, AVOC, which are gas impermeable.
That makes perfect sense, as our primary base material appears to be nylon. I strongly believe we should consult with Vadim Vasilievich for his expert opinion and guidance on this matter.
I was going to say, write the formula for this fabric in the chat. But I won't, it's commercial secret. This was mentioned, a couple questions, lips sealed. Speak in metaphors.
Perhaps it is indeed our competitors who have joined our webinar. And what about heating the helium? Is it just for the initial ascent and then it will subsequently cool down?
This is indeed one of the systems, yes, for significantly increasing lift in hybrid airships during the critical phase of takeoff. Because that's right, I saw in the chat that someone calculated that if you were to lift the entire load with propellers, you'd need huge propellers and massive engines. So what's the point of having an airship then? Precisely so, you don't need huge propellers and massive engine is a dirigible that gets loaded somewhere, can use a combined system, drawing from some ground-based heat or energy sources. You can heat the helium, gain greater lift, and then turn and power up the propellers. Then, when everything relies on aerodynamics and the helium cools down, you no longer need that heat, and the lift is no longer necessary, just like during landing, you don't need it either. And once it's unloaded, yes, such solutions are being considered. There are many different methods, and this is one of the good ones. Yes, one of the best. Carrying helium heating system on board is also excellent. That's a good solution too.
Well, that's all the questions I have for you. It seems we've answered everything, so I think...
Oh, I see another interesting question on Vikontakte. Can a large dirigible be towed by an airplane? Only if it's a plane whose speed perfectly matches, so it doesn't break away. But that seems quite unrealistic.
Vice versa, towing a plane with a dirigible also seems odd.
Yes, here's a question. Is a synchronous motor completely unsuitable for dirigibles? No, it's actually quite suitable. Indeed, it is very much so. It's just that, ideally, you should consider them starting from around 300 kilowatts. Moreover, it's a separate and distinct design process and so on and so forth. At the company you're talking about, they are currently busy with something else, as you know, so everything has its time.
So, do you have any more questions? I'm out of them.
In Moscow, there's a prominent company known as Cognitive Pilot, which is a recognized leader in advanced machine vision systems. We are certainly aware of their work, but no, we do not currently collaborate with them. Overall, everything else, like you already mentioned, Gazoliot, you just didn't say, maybe it could be called that, well, Aerolet also seems Russian, let. And Aero, that's probably from mentioned Greek, quite likely, just like Gaza. So much has been done, and yet you don't show anything. It's a bit of a flaw, but I provide concentrated information, that's why it stands out. Whereas for us, it's just everyday routine, like watching a movie. The main character always has something happening, but in real life, for some reason, that never happens to anyone. We are constantly trying, experimenting, and it's quite possible that very soon we'll come up with some brand new content format to effectively cover all of this important information.
So, are there any more questions?
Alright, go ahead and hit the like button.
Yes, and be sure to share this webinar, maybe send it to a friend or acquaintance so they can get to know this field as well.
Yes, if you're truly happy with our webinar format, the Q&A session and the direction we are heading, we would appreciate it.
So, I guess we'll wrap it up for today.
Will the company be holding an open house for investors? Yes, we will. In fact, we've already held, investors have visited our office, and as it happened, some investors from Africa even managed to visit the airfield. We are planning to hold another one, as we've mentioned before, and we're getting ready for it. So, this summer has turned out to be quite something, as you can clearly see, but we sincerely hope the weather will significantly improve, and you'll get a wonderful chance to visit the airfield, where you'll see the NOVA-01 and NOVA-1 in actual flight, as well as visit the main office. But all of this will be organized around certain events, of course. So yes, stay tuned for announcements. Alright, I don't see any more questions currently. What are our immediate plans for the very near future? To fly again, to thoroughly finish up, to fly on that particular one, to continue diligently building the gondola, and to meticulously set up the envelope production, to work full force at the metal cutting and metal working production, to create the power unit, to write programs, to obtain certifications, to build good relations with Rosaviatia, and to join the special economic zone.
There are many plans.
Yes. To present in Dubai. So we're working.
Yes, thank you to everyone who was here today, who asked questions. I'm especially grateful for your suggestions that you write in our chats, which we also have. And once again, I ask you to stay active, leave reactions, write comments. This really helps the project develop. Thank you all, and see you soon, friends.
Alright, goodbye everyone.
Bye for now then.
Solar Group presents. This was once just a dream of the skies, the freedom of flight, of round-the-world journeys. Yet we've made it happen. But what did it take? Our dreams became our goals. Our concepts turned into our plans. Our ideas have transformed into a roadmap and production technology. And the years ahead are booked out with development and construction, components and materials, model manufacturing and testing. All this marks the progress from dream to result. Join us on this journey. Solar Group presents a new generation of airships. The best way to predict the future is to create it, so let's do so together.